So in the last session, so just we covered about list. So we covered what is the list interface and what are various implementation classes for the list. Array list is the first implementation class, linked list is the second implementation class, vector and stack. Okay, array list, linked list, vector, stack, these are implementation classes of list. We covered already all these things. Are you getting? We covered already all these things we covered, and in addition to list module, so the next thing, what are various cursors available in Java? Enumeration, iterator, list iterator. What is the difference between or comparison between these? So when we should go for iterator or when we should go for list iterator, or what is the difference between iterator, list iterator, like so. Cursors part also we completed, right? Now the next terminology, a bit very important terminology. Now the next terminology. So what is the next terminology here is second module, set. Set is the second module, right? So for collection, okay, so collection we covered, list part anyway we discussed. Now the second part what we have to discuss is nothing but what? Set. Have you remembered what are various implementation classes of set? Hash set, hash set, linked hash set, hash set, linked hash set, and then we should go for what? Sorted set. Okay, sorted set is an interface. Next one, navigable set, and then implementation class for that is a tree set. Okay, that's all. These are things we have to discuss. Yeah, the part of second module. Okay, now in which versions these came, not required to keep any explanation. 1.2, 1.2, 1.2, 1.4, 1.2, 1.6, 1.2 version. Are you getting? First keep subheading set. Subheading set. Okay, under set, better to write all these things. Set. So take this diagram anyway, right? Collection, set. Next, hash set, linked hash set, linked hash set. Next, sorted set, navigable set. Last one, tree set. Collection, set, hash set, linked hash set, sorted set, navigable set, followed by tree set. Tree set. Hash set, linked hash set, sorted set, navigable set, tree set, like. Are you able to understand, right? So this part we have to discuss at the part of second module. Okay, anyway, right? Now when we should go for set, okay, you know when we should go for set. Set is the child interface of collection first. When we should go for set, if you want to represent a group of individual objects, I want to represent a group of individual objects where duplicates are not allowed. Duplicates are not allowed. Insertion order not preserved. Duplicates are not allowed. Insertion order not preserved. Then we should go for set. Sir, I don't want order. Order I don't want. Not interested in the order. But duplicates are not allowed. Then we should go for which concept is a set. Set itself is the concept. Clear, right? Okay, add. Set is child interface of collection. Set is child interface of collection. Set is the child interface of collection. Set is the child interface of collection. Next, second. If we want to represent a group of individual objects, as a single entity, if we want to represent a group of individual objects as a single entity, if you want to represent a group of individual objects as a single entity, where 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 duplicates are where duplicates are where duplicates are where duplicates are not allowed, where duplicates are not allowed, and the insertion order not preserved, and insertion order not preserved, insertion order not preserved, insertion order not preserved, preserved. Okay, that's all. Are you getting? So duplicates are not allowed and insertion order not preserved, then we should go for set. Okay, well, but now there is one very important conclusion. Make sure, sir, collection contain, have you remembered, there are 12 methods we discussed in the last class. How we can add an object, add method. I want to add a group of objects, add all, remove all, retain all, clear, is empty, size, iterator, like there are some methods we covered already in the collection, right? So all collection methods happily we can apply related to the set. Next, set itself contain how many methods are there? Okay, so already 12 methods we covered from the collection interface. Then set itself contain how many methods? So do you know, almost around 58 methods are there. Okay, how many methods are there? 58 methods are there. These 58 methods we are going to discuss. Are you getting right? Okay, this are you ready for 58 methods? Are set interface contain how many new methods? 58 methods are there. These 58 methods we have to discuss, so that 12 plus 58, 70 methods happily we can apply on these set implemented objects, right? Okay, at the point, set interface doesn't contain, set interface doesn't contain any new method. Set interface doesn't contain any new method, and we have to use only collection interface methods, only collection interface methods. Okay, so I hope you can aware now. Okay, so here my here don't so 58 methods are not there, just I'm checking what about your feeling if I use 58. Okay, so 58 is not there. Only the methods which are available in the collection, those methods only we have to apply for the set also, right? Okay, that's all. So this is related to set interface, right? Now no new method, that's why not required to discuss anything related to this set. Now what is the first implementation class for set? Is nothing but hash set. Now keep supporting hash set. Okay, here take a bit special care. What is the hash set? Like here, legend, sir, the underlying data structure for a hash set is hash table, based on hash table data structure. Hash set concept came. Okay, first one, the underlying data structure for hash set is hash table. First point. Second point here is duplicate objects are allowed or not allowed? Duplicates are allowed or not allowed? Not allowed. Duplicate objects are not allowed because it is the set, right? Next, insertion order, is it preserved or not preserved? Insertion order is not preserved, and in the case of hashing related data structures, all objects will be inserted based on hash code. For every object hash code is there in the java.lang package we covered. For every object hash code is there, so all objects will be inserted based on hash code of the objects. Okay, for every object hash code is there, based on that hash code the objects will be inserted. That's why insertion order not preserved, but all objects are inserted based on hash code, of objects, right? Okay, like next, Sir, null insertion is possible or not? Okay, they say happily we can insert a null, there is no problem at all. But how many times we can insert null? Only one, because duplicates are allowed or not allowed? Not allowed. That's why null insertion possible. But how many times we can add is nothing but only one. Can you tell heterogeneous objects are allowed or not allowed? Heterogeneous objects allowed or not allowed? Oi, I covered in the last session. Except tree set and tree map, everywhere heterogeneous objects are allowed. That's why heterogeneous objects are allowed, no problem at all. Next, this hash set implements, do you know serializable interface? Hash set implements serializable, clonable interfaces, serializable, clonable, random access. Is it possible or not possible? No. Is nothing but random access is not there. Serializable, clonable, random access is nothing but like, okay, next. Sir, just one point you people should aware. Wherever hashing is there, hashing related data structures are best suitable for search operation, right? Wherever search operation is our common operation, frequent operation, which data structure is the best choice is nothing but hashing, or hashing related data structures are best choice. Okay, because hashing algorithm, have you remembered? Search, number one search algorithm up to today is nothing but hashing only. Wherever our frequent operation is the search operation, then better to go for what? Hash set, right? Is it clear for all of you? These are various important loopholes related to hash set. Okay, at this point, hash set. At first point, the underlying data structure is underlying data structure is hash table. Underlying data structure is hash table. Underlying data structure is hash table. Next, second, duplicate objects are not allowed. Duplicate objects are not allowed. Next, insertion order is not preserved. And it is based on hash code, of objects, Next, null insertion possible. Null insertion is possible. Within bracket only once. Only once. Next, heterogeneous objects are allowed or not allowed? Allowed. Heterogeneous objects are allowed. Heterogeneous objects are allowed. Next, implements serializable and clonable. But not random access. Implements are serializable and clonable but not random access. Interface. Implements are serializable and clonable but not random access interface. Next, hash set is the best choice. If our frequent operation is hash set is the best choice. If our frequent operation is search operation. If our frequent operation is search operation. Okay, that's all. Any explanation is required about this terminology? Okay, the same. So hash table. Okay, what about duplicates like underlying data structure? These are various important properties related to what? Hash set, right? But here one point we covered already. Sir, can you tell duplicates are allowed or not allowed? Duplicates are not allowed. Now just observe. So here see this one. I have hash set is there. Hash set h is equal to new hash set. Sir, I created one hash set object. Okay. So h dot add of a. Sir, I am adding a. No problem. Happily we can insert. Once again I am trying to add h dot add of a. Can you tell, is it allowed or not allowed? Not allowed. If we are trying to insert duplicate object, what will happen? What will happen? If we are trying to insert duplicate object, what will happen? Make sure add method return type is boolean. Have you remembered in the last class somewhere we covered add method return type is boolean. If we are trying to insert duplicate objects, we won't get any compile time error or runtime exception. Simple add method returns false. Okay, this is. So if you want, you can just take SOP of like this. Are getting h dot add method return type I am trying to print, then what the answer we are going to get? False. If you print SOP of h dot add first time, because first time it's not duplicate, right? Successfully inserted. That's why what it's going to return? True itself is going to return. Are you getting? By default hash set won't allow duplicates. Of course, by default or anyway, hash set won't allow duplicates. If we are trying to insert duplicate objects, we won't get any compile time error or runtime exception. Simply add method returns what? False. Clear for all of you, right? Okay, take a note. Keep star for this. In hash set, duplicates are in hash set. Duplicates are in hash set. Duplicates are not allowed. In hash set, duplicates are not allowed. Duplicates are not allowed. Duplicates are not allowed. If we are trying to insert duplicates, then we will get, wait. If we are trying to insert duplicates, then we won't get any compile time or runtime errors. We won't get any compile time or runtime errors. And the add method simply returns false. Add method simply returns false. Add method simply returns false. Okay, at this point note. Example. Hash set h is equal to new hash set. Hash set h is equal to new hash set SOP of h dot add of a. Sir, first one is not duplicate because we are inserting a first time. True is the answer. SOP of h dot add of a, the return type itself is false because it is a duplicate. It won't be inserted, right? That's all. Completed, right? So if we are trying to insert duplicates, what will happen? Now the terminology is very clear for you people, right? Okay. So now the next one, legend. This point well. It is also very important terminology. Okay, make sure. Sir, I am taking legend a bit important terminology what we have. Sir, I am taking constructors, array list, linked list, vector stack. Everywhere we covered constructors, but related to hash set, there is a small difference is there in the constructors. What that point you have to aware. Okay, keep submitting constructors. constructors constructors constructors. Okay, here just observe, take a bit special care. Sir, in our collection framework there are several hashing related data structures are there. There are several hashing related data structures. We have hash set is there, we have linked hash set is there, hash set, linked hash set. Next we have hash map is there, and linked hash map is there. Now listen, hash map, linked hash map is there. Next weak hash map is there, weak hash map is there, and identity hash map is there. Have you observed? Identity hash map is there. Like there are several, all are related to hashing based data structures only. Are you getting? So once you know constructors of hash set, so for all remaining the same constructors I'm going to use. Are you getting? That's why. So learn carefully. So in the all remaining, just I won't keep much explanation because these constructors already we covered in hash set, like I will spell out. That's why make sure learn the constructors clearly, because here one small loophole is there. That part I will discuss. So first constructor, anyway our known constructor, nothing will be there. Sir, hash set h is equal to new hash set. Sir, creates it creates an empty hash set object. Are you getting? Normal array list style is equal to new array list, same style, it creates an empty hash set object. Are you getting? But here what is the default initial capacity? The default initial capacity for hash set is 16. Are you getting? What is the default initial capacity for a hash set? 16. And this is the initial capacity. And default fill ratio 0.75. Immediately you may get the big doubt. Sir, default fill ratio 0.75, default initial capacity is what? 16, default fill ratio 0.75. Sir, initial capacity no problem at all, our known concept only. Initial capacity is our known concept. But what is this concept? Default fill ratio is nothing but 0.75. Have you observed? Fill ratio, which is also known as load factor. Load factor, what it means? Sometimes in the interview room also may be a chance. In hash set, what is the default fill ratio? 0.75. What is the meaning of fill ratio? Like you should compulsory aware what is the meaning of fill ratio or load factor, right? Now observe, very simple. In normal array list, what is the default initial capacity? Array list, what is the default initial capacity? 10. When a new array list object is going to be created after completing all 10 elements, if I am trying to insert 11th element, after completing all 10, if I am trying to insert 11th element, then a bigger array list object is going to be created. Correct or not? Let me repeat once again. So the default initial capacity of array list is 10. After filling 10 elements, if I am trying to insert 11th element, now a bigger array list object is going to be created. So I have to wait until completing 100%. After that, a new object, if I am trying to insert, then a bigger array list object is going to be created. But in the case of hash set, okay, I don't want to wait until completing 100%. Are you getting? I don't want to wait until completing 100%. I have to, after filling 75% ratio only, can you please create a bigger array list object? After filling 75% only, can you please create a bigger array list object? Okay, like we can able to take. Is it clear for all of you? Right? Okay. Now after filling 75% ratio, then a bigger array list, a bigger hash set object is going to be created. Clear for all of you? Right? This ratio itself is nothing but what? Fill ratio, right? Are you getting the point clearly? So what is fill ratio? After filling this much ratio, a new hash set object is going to be created. I don't want to wait until completing 100%. This ratio is nothing but what? Fill ratio. Have you observed the word? Fill ratio. After filling 75%, a new hash set object is going to be created. Or after loading this much factor, a new hash set object is going to be created. Okay, this word you should have clear clarity, right? Okay, at this point. first constructor. Hash set h is equal to new hash set h is equal to new hash set add creates an empty hash set object, creates an empty hash set object with the default initial capacity 16 and the default fill ratio what is the default fill ratio? Default fill ratio 0.75. Default fill ratio 0.75. That's all. So anyway, I will give the notes what is the fill ratio at last. Are you able to understand? Default initial capacity 16, default fill ratio is nothing but what? 0.75. Now second terminology, second constructor legend. Same hash set h is equal to new hash set of h is equal to new hash set of int initial capacity. Sir, I don't want a default initial capacity 16. I want my initial capacity at the 1000. Then how we can do is nothing but like this. Hash set h is equal to new hash set of int initial capacity creates an empty hash set object with the specified initial capacity, right? Is it clear for all of you? Okay, this. But what is the default fill ratio? 0.75. Fill ratio is the same, but initial capacity instead of 16, we can provide our own capacity, right? Okay, at this point. Hash set h is equal to new hash set h is equal to new hash set of int initial capacity add creates an empty hash set object with the specified initial capacity and default fill ratio can I spell out what is the default fill ratio? 0.75 and the default fill ratio 0.75. Okay, that's all. So this is the second constructor what we have. Okay, third one, hash set h is equal to new hash set of sir, not only initial capacity, I want to customize fill ratio also. Regarding my own fill ratio, I want to specify int initial capacity, comma float fill ratio. Sir, our own initial capacity, our own fill ratio. Sir, after completing 75%, automatically a new asset object is going to create. But I don't want new object just at 75%. Sir, after completing 90%, can you please create a new asset object? Then I have to specify here what the value 0.9. I get a 90%, 0.9 like. Okay, take third constructor. Hash set h is equal to new hash set of h is equal to new hash set of int initial capacity, comma float fill ratio, float fill ratio. Not required to keep any explanation because you know, okay, what is the, just we are customizing fill ratio and initial capacity, right? Next, fourth constructor, very important, of course, our known constructor only. Do you know hash set h is equal to new hash set of hash set h is equal to new hash set of what? Collection C. Do you know creates an equivalent hash set object, creates an equivalent asset object with equivalent asset object for the given collection. Maybe sometimes our requirement is for the given array list, can you please create an equivalent hash set? Just pass array list object, automatically equivalent hash set object by default we are going to get. Sir, I have vector is there. For the given vector, an equivalent hash set I want to create. Then what we will do is nothing but hash set h is equal to new hash set of is nothing but vector object. An equivalent hash set object will be created. This constructor meant for interconversion between collection objects, right? Regarding interconversion for any collection, now I can able to create an equivalent hash set object. So this type of constructor available in every collection. Have you remembered, right? Okay, add fourth one. Hash set h is equal to hash set h is equal to new hash set of hash set h is equal to new hash set of collection C. Hash set h is equal to new hash set of collection C. Collection C. Add creates an equivalent hash set. Creates an equivalent hash set. Creates an equivalent hash set for the given collection. Creates an equivalent hash set for the given collection. For the given collection. Creates an equivalent hash set for the given collection. Okay, that's all. Are you getting? So these are the four constructors what we have. An equivalent hash set for the given collection is nothing but like. So do you know this constructor meant for interconversion between collection objects from one collection to another collection if you want. Then related to hash set, this is the constructor, right? Add this constructor meant for interconversion between collection objects. Interconversion between collection objects. This constructor meant for interconversion between collection objects. Okay, that's all clear for all of you, right? Okay, so these are the four constructors what we have related to hash set, right? Okay, now just observe this one. Let me convert this total discussion into a small example form so that you can aware the properties of hash set, right? Here legend very thing will be there, but here before that I have to add one important note. Have you observed, right? So what is fill ratio or what is load factor? Keep submitting. Fill ratio or load factor. Fill ratio or load factor. Fill ratio or load factor. So we covered already, but just let me give the notes, that's all. Can you tell what is the fill ratio or load factor? After filling how much ratio? A new hash set object is going to be created. That ratio is by default considered as fill ratio, or otherwise simple. After loading how much factor? Are you getting? After loading how much factor? After loading 0.75. Can you please create a new hash set object? Is nothing but like after loading how much ratio or how much factor, a new hash set object is going to be created. That thing is by default considered fill ratio or load factor. Is it clear, right? So 0.75 fill ratio. Sir, fill ratio 0.75 means what? After completing or after filling 75% ratio, automatically a new hash set object is going to be created. Correct or not? Okay, this add. Keep submitting fill ratio or load factor. Under that add. After filling, how much ratio? After filling how much ratio? After filling how much ratio? A new hash set object will be created. After filling how much ratio? A new hash set object will be created. After filling how much ratio, a new hairset object will be created. A new hairset object will be created. After filling how much ratio, a new hairset object will be created. Comma, this ratio is called. Comma, this ratio is called. This ratio is called. This ratio is called. Ratio is called. Is called fill ratio. This ratio is called fill ratio or load factor. Fill ratio or load factor. Fill ratio or load factor. Load factor. For example, fill ratio. For example, fill ratio 0.75 means. Fill ratio 0.75 means. 0.75 means after filling 75% ratio. After filling 75% ratio. After filling 75% ratio, a new hairset object will be created automatically. After filling 75% ratio, a new hairset object will be created. A new hairset object will be created. A new hairset object will be created. That's all. Are you able to understand, right? Okay, this is, make sure what is the meaning of fill ratio or load factor, right? Now not required to keep any explanation about this one. Now this total discussion, let me convert into an example style so that you people can aware, right? Okay, here see. Hash set demo. Simple. Take a bit special care to understand this one. Sir, here I am taking. Have you observed? Import java.util.star class hash set demo public static void main hash set h is equal to new hash set. Sir, just I am creating one hash set object h dot add of b c d z null 10. Okay, this is, and sop of h dot add of z. Sir, z is already there or not? Yes. If I am trying to insert z, what will happen? False is the answer. That's why false. Suppose here this is, and sop of h. Can you tell what the answer now? Good. B, C, D, Z, null 10. I will give left and right. So because it is the hash set, insertion order preserved or not preserved? Not preserved. If it is not preserved, how you can tell B, C, D, Z, null 10? Okay. So hash set, the insertion is based on hash code. We don't know what is the hash code of these objects. That's why I don't know what is the exact answer. Are you getting that? Because if I know hash code, then I can able to tell this is the output. But I don't know what is the hash code of these objects. That's why I don't know what is the output by default we are going to get. Are you getting? But so in hash table somewhere, hash map somewhere, based on hash code, how the object will be inserted, I will show programmatically. Internally memory level representation I will explain, but here just for this example sake, we don't know hash code of these objects, we don't know in which order the objects will be inserted. That's why so we can't give the guarantee for insertion order. Okay, now observe this one. Here say h dot add of b c d z null 10 like, and we are trying to insert duplicate objects. What will happen? Now let me compile and run this code. Here Java say hash set demo dot Java. Yes, Java hash set demo. Okay, like, do you know what is the output by default we are getting? False. Okay, this is the false, and then null dbc10z is nothing but like false is the answer. And can you tell, is it insertion order? Ayo, is it insertion order? No, because first pcdz actually insertion order, but null dbc10z is nothing but it's not insertion order. Simple. So here duplicate objects are allowed or not allowed? Not allowed. Heterogeneous objects are allowed or not? Allowed, because string object, integer object, both we are adding. Null insertion is possible or not? Yes, possible. Insertion order is preserved or not preserved? Not preserved. If we are trying to insert duplicate object, what will happen? False. All properties of asset is nothing but here. Okay, take this example. take clearly. So take clearly. What is the output by default we are going to get? Is that clear for all of you, right? Hash set h is equal to new hash set h dot add of b c d z null 10 sop of h dot add of z. False is the answer. Sop of h. So the output. Have you completed the program, right? Now take clearly the output. What is the output by default we are going to get? Add. So for this SOP anyway you took the false, okay, and then next one null dbc 10z, null dbc 10z, null dbc 10z itself is the answer. I hope is clear for all of you, right? Okay, this is. Now the next one, make sure you people should have clarity about this terminology, right? So there is one special concept related to hash set. So named with the linked hash set. Are you getting? Named with the linked hash set. Okay, keep subheading. Linked hash set. Linked hash set. Linked hash set. So sometimes maybe a chance to ask what is the difference between hash set and a linked hash set. Okay, maybe a chance to ask, sir, what is the difference between hash set and linked hash set? Linked hash set. Okay, don't tell the difference between these two is nothing but, okay, linked. Of course, linked is the difference, but what is the purpose or what is the meaning of this linked hash set? There's a big difference is there between these two words, right? What is the difference is linked hash set is exactly same as hash set. Exactly same. Methods, constructors, everything is the same, but only one small difference. What is the difference is, sometimes my requirement is, sir, I don't want duplicates. Duplicates are not allowed. Happily you can go for a set. Happily you can go for a hash set. But insertion order must be required. Are you getting mixed, Anna? So set properties, duplicates are not allowed, but insertion order not preserved. So list property is insertion order preserved, duplicates are allowed. Mixed thing I want. List and a set mixed properties I want. Something like duplicates are allowed or not allowed? Not allowed. But insertion order must be preserved. Is nothing but mixed. Then we should go for linked hash set. Are you getting right? So how the here hash set duplicates are not allowed. Linked means what? Internally it is going to use linked list. Are you getting? It is underlying data structure here is, do you know, hash table. What is the underlying data structure for a hash set? Hash table. But underlying data structure for linked hash set is linked list plus hash table. Linked list plus hash table. That's why insertion order preserved, duplicates are not allowed. So if you don't want duplicates, but insertion order must be preserved, then we should go for special data structure. What is that concept? Is nothing but one linked hash set. Is it clear for all of you, right? When we should go for linked hash set, what is the difference between hash set and a linked hash set? Just observe in this example, just whatever example we covered. Have you observed? Hash set h is equal to new hash set h dot add of b c d z null 10. Sir, in which order objects are inserted? B, C, D, Z, null 10. Let me consider the output what we got. Null D, B, C, 10, Z. Is the insertion order preserved or not preserved? Not preserved. Sir, I want insertion order, but duplicates are not allowed. Then replace hash set with the linked hash set. Now observe this one, linked hash set. Just replace hash set with the linked hash set. What is the output? By default we are going to get here is, have you observed, false. B, C, D, Z, null 10. B, C, D, Z, null 10 is nothing but like. Any explanation is required about this terminology? Okay, this make sure you people should have clear clarity about this terminology, right? B, C, D, Z, null 10 itself is nothing but like. Any explanation is required? Okay, so can you tell what is the difference between hash set and the linked hash set? Everything exactly same, only one difference. In hash set, duplicate insertion order not preserved, but in linked hash set insertion order preserved. Clear for all of you at this point? Keep submitting. Linked hash set under the first point, at the first point, it is the child class of, it is the child class of, it is the child class of hash set, it is the child class of hash set, child class of hash set, hash set, hash set. Next up, it is exactly same as hash set, it is exactly same as hash set, it is exactly same as hash set within bracket, exactly same as hash set within bracket, including constructors and methods, including constructors and methods. It is exactly same as hash set including constructors and methods, including constructors and methods, bracket close, except the following differences, except the following differences, except the following differences, except the following differences. Okay, better to take the table first. Hash set, linked hash set, hash set, linked hash set, linked hash set, hash set, linked hash set. Do you know, can you tell, listen, what is the underlying data structure for a hash set? Hash table. But underlying data structure for linked hash set is a combination of hybrid data structure, a combination of linked list plus hash table. Are you getting? First point, legend first. Second one, here insertion order preserved or not preserved? Insertion order not preserved, not preserved. But what about insertion order here? Preserved. Insertion order preserved. Next, so do you know hash set introduced in which version? Introduced in 1.2 version, introduced in 1.4 version, right? Okay, that's all. Beyond that, there is no difference between hash set and linked hash set, right? If any person can ask in the interview room what the difference between hash set and linked hash set, then you have to tell this one. Okay, at the point, first point, the underlying data structure, the underlying data structure is hash table. Underlying data structure is a hash table. Underlying data structure is hash table. Next, other side. Underlying data structure is a combination of, underlying data structure is a combination of, underlying data structure is a combination of linked list and a hash table. Underlying data structure is a combination of linked list and a hash table. Linked list and a hash table. List and a hash table. combination of linked list and hash table, linked list and hash table. Okay, second point, insertion order not preserved, insertion order not preserved, insertion order not preserved. Next, other side, insertion order preserved, insertion order preserved. Third point, introduced in which version? Introduced in 1.2 version, introduced in 1.22 version. Next, introduced in 1.4 version, introduced in 1.44 version, introduced in 1.4 version. Okay, that's all completed, right? So introduced in which version? 1.2, 1.4 version, like that's all. So now related to this example, so add, just close the table, and then in the above program, so don't ask what is the above program, already there in your notes. Okay, hash set program. In the above program, if we replace hash set with linked hash set, in the above program, if we replace hash set with linked hash set, if we replace hash set with linked hash set, hash set with linked hash set, then hash set with linked hash set, then the output is, if we replace hash set with the linked hash set is a single word, don't give a space in the middle, it's a class name. If we replace linked hash set, then the output is, better to take this one, square bracket B C D Z null 10, B C D Z null 10, B C D Z null 10, 10. That's all clear, right? So this is one thing what you people should remember, that is add answer, that is next statement, that is insertion order, that is insertion order preserved, that is insertion order preserved, insertion order preserved. Okay, next a small point I have to highlight here related to linked asset here, just observe. You know, here we know cache memory, cache based applications like cache memory. So what is the cache memory or cache based application? What it means here, see. Sir, we have primary memory is there. The people who are coming from computer science background, you should be aware. Primary memory is nothing but what? RAM. Okay, primary memory. Secondary memory is there. Secondary memory is nothing but what? Hard disk. Which is a costly memory? Primary memory is nothing but RAM is the primary memory, which is more speed wise, primary memory. So secondary memory is permanent storage, but the problem is not that much speed. Suppose assume if I require to communicate with a secondary memory every time, primary memory speed is high, secondary memory won't respond that much with that much speed. So if I require to communicate every time with the secondary memory, overall performance of the system is going to be down. Correct or not? Because this person is not that much speed. Okay, so this person is a high speed component, but he won't maintain that speed. That's why compulsory what we have to do is nothing but here, do you know, so here the overall performance of the system is going to be down. Okay, this is just observe. So there is మనం తెలుగులో ఏమంటామన్నా ఒక ఎద్దుల బండి ఉందనుకోండి, దాని తెలుగులో ఇంగ్లీష్ వాట్ వై కాల్, ఓకే. సో దెర్ ఈజ్ సపోజ్ ఇయర్ వన్ ఒక ఎద్దుని ఏమంటాం, ఓకే, బుల్. ఓకే, ఇఫ్ ఇట్ ఈస్ స్లో, ద అదర్ వన్ ఈజ్ నథింగ్ బట్ ఎ బిట్ ఫాస్ట్, దెన్ వాట్ విల్ హ్యాపన్? The vehicle is that thing will go slow or speed? Obviously, right? So one రెండిట్లో two bulls, one bull is very slow, but the other one is nothing but speed. Okay, this. But there is no use of this speed component. Are you getting? Because the other component is the slow. If both are with the speed, then only that vehicle can move a bit faster. Yeah, one memory is nothing but respond very speed, but the other memory is nothing but won't that much speed. That's why what we have to do is in the middle we have to go for some memory. Okay, caching memory in the middle. Repeated calculations, repeatedly required code we are going to keep here. Are you getting? So if I require to communicate with secondary memory, first I will check is it there in the cache. If it is there in the cache, happily I can get. So cache speed is much faster than secondary memory. That's why overall performance of the system by default is going to be improved. Are you getting? Cache memory concept came in the middle just to improve, because the repeated results, repeatedly required code we have to store here. Are you getting? But cache memory is nothing but costly memory. Okay, this is costly memory only. So in cache there are some properties who are going to be satisfied. Cache memory, there are some properties who are going to be satisfied. So the first thing here is in cache memory there are some properties are going to be in cache memory there are some properties are going to be satisfied. What is the first property here is, listen, duplicates are not allowed. Duplicates are not allowed is nothing but like duplicates are not allowed. First point. Second point is, okay, insertion order must be preserved. Sir, in which order we saved? In the same order only. In which order we saved? In the same order only we have to store the objects. Are you getting? So is nothing but duplicate results, duplicate code we are not allowed to save. Second thing, in which order we saved? In the same order only internally should be represented. Insertion order must be required. Duplicates are not allowed. Duplicate code is not allowed. Which data structure can satisfy these properties on a linked hash set? Are you getting? So that's why the very common use of linked hash set is for developing cache based applications. Are you getting? But how to develop and so on, not in our scope, not required to worry. Just revere this point, right? Linked hash set very commonly used area, application area is nothing but what? Is to develop cache based applications, right? Okay, take a note. In general we can use a linked hash set. In general we can use a linked hash set. In general we can use a linked hash set. Linked hash set. In general we can use a linked hash set to develop cache based applications. To develop cache based applications. To develop cache based applications. Cache based applications where duplicates are where duplicates are not allowed. Where duplicates are not allowed. Duplicates are not allowed. Not allowed. And insertion order. Duplicates are not allowed and insertion order. Duplicates are not allowed and insertion order not preserved. Duplicates are not allowed and insertion order preserved. Preserved. Duplicates are not allowed and insertion order preserved. Okay, that's all. Completed, I hope. So what is hash set and what is linked hash set is nothing but like the terminology, right? After that, what is the next concept? Can I spell out what the next one in our diagram? Sorted set. Keep submitting. Sorted set. Sorted set. Collection is there, set is there for this sorted set. Okay. So first point here is sorted set is the child interface of sorted set is the child interface of set. When we should go for sorted set? The name itself indicates, have you observed? If you want to represent a group of individual objects where duplicates are not allowed, without duplicates, because set property without duplicate, but all objects should be inserted according to some sorting order. Are you getting? Where all objects should be inserted according to some sorting order. Then we should go for what? A sorted set. Okay, this is, yeah, sorting must be required. Boss, can you please insert all student objects according to roll number wise, according to alphabetical order of names, or can you please insert all employee objects according to ascending order of their employee IDs? Are you getting? Or can you please insert all integer objects according to ascending order? Or can you please insert all string objects according to alphabetical order? How you can implement sorting for individual objects is a sorted set is the concept, right? Clear? Okay, add up to this. Sorted set is the child interface of sorted set is the child interface of sorted set is the child interface of set. Sorted set is the child interface of set. Child interface of set. Sorted set is the child interface of set. Next, if we want to represent a group of individual objects, if we want to represent a group of individual objects, if we want to represent a group of individual objects, if we want to represent a group of individual objects according to some sorting order, without duplicates, then we should go for sorted set. That's all. Are you getting? So here, so what is sorted set? Okay, what is the sorted set? So if you want to represent a group of individual objects according to some sorting order where duplicates are not allowed, then we should go for what? Sorted set. But here one small twist is there. Sir, we covered collection. There are 12 methods we discussed already. But set, we didn't cover any methods, right? Because no new methods. We have to use only collection interface methods only. Okay. But now we are discussing which concept? Sorted set. Just 1 minute. Legend this one. Sir, suppose in our mathematics somewhere, okay, set theory or sets relations, functions, like in the discrete mathematics or basic mathematics somewhere you may have. Suppose I have 3 sets are there. 1, 2, 3, 3, 2, 1, 2, 1, 3, okay, 2, 3, 1, like I have some sets are there. Can I use the term all these sets are equal or not? Ayo, set theory in the sets relations functions, like in your discrete mathematics or normal mathematics you may have. So here these sets are equal or not? Equal, because in the set the elements are there or not we have to check, but in which order elements are there not important. Normal sets, that's why. So all these are equal. If these are equal, sir, what is the first element? These are equal. What is the first element? The first element can be anything, we can't tell. Sir, here 1, but here 3, but here 2, but here 2 is nothing, but you can't tell. Normal set, first element, last element, such type of terminology not applicable. Are you getting that? Okay, this is. But assume, sir, it is, okay, assume it is a sorted set. Sir, elements are 1, 2, 3, that's all. Sorted set, all elements are inserted according to some sorting order. Now can you tell what is the first element? 1. Now you can able to tell, sir, 1 is the first element. Sir, what is the last element? Is nothing but 3. Oh, if it is the sorted set, now what is first, what is last, there is a clear meaning is there, correct or not? That's why sorted set interface define specific methods, but these methods are not applicable for normal set. Okay, remember this one. Sorted set contains some specific methods are there. Okay, but these are not applicable for normal set objects, right? So which methods are there, okay, related to sorted set? Just observe this one. Sir, what specific methods related to sorted set? Now assume that this is my set 100, next 101, okay, 104, 106. So next 110, 115, 120 is there. Can I use the term, is it a sorted set or not? Yes, is it a sorted set or not? Yes, it is a sorted set. Now what is the first? Which one is the first? Yeah, if you want to know what is the first, we have to call first is the method. You have to call which method? First. Can you tell what is the first? First is which element is the first element? 100 is the first element. Similarly, you can ask what is last? Boss, what is the last object? What is the last? 120 is the last object. Next, boss, can you please tell which elements are there before 106? Are you getting? Which is the header part of 106? Head part of 106. What is the method name here? Head set of 106. Head set of 106. It returns, do you know, it returns sorted set whose elements are less than 106. Less than 106. Do you know what is that one? 100, 101, 104. That's all. Not less than or equal to. Less than 106 is nothing but like. Next, if head part you can able to tell, then automatically you can tell tail also. Is nothing but what is the tail set? Tail set of 106. What is the answer now? Tail set of 106. Make sure the elements which are greater than or equal to 106. Here equal symbol also there, inclusive. Greater than or equal to 106. What is the answer? 106, 110, 115, 120, right? Are you getting? Sir, header part and tail part you can able to tell. Then subset is nothing but like, now next element, here see this point. Subset of 101, 115. 101, 115 subset. Can you tell what the answer now? The elements which are greater than or equal to 101 and less than 115. Observe the end condition. Inclusive first element but exclusive last. Which are greater than or equal to 101 but less than 115. What is the answer? Greater than or equal to 101. 101, 104, 106, 110. That's all. Are you getting? These are 5 specific methods what we can apply on sorted set. It is related to only sorted set. You can't apply anywhere else. Next, one more method is there. Let me highlight this method also. So, comparator method. Comparator method is there. Returns comparator object. Okay, it returns what? Comparator object. You know, in sorted set, elements are inserted based on some sorting. Correct or not? Sir, what is underlying sorting? I want to know what is underlying sorting. In this case, which is sorting we used? Ascending order. Are you getting? If you want to know underlying sorting, then we should go for which method? Comparator method. It's a big concept of 3 hours we are going to spend on this concept. Not required to worry. Just observe. Comparator method returns comparator object which describes underlying sorting technique. Is it ascending order or is it descending order? Like, it is going to talk about internal sorting technique, right? Suppose I am using normal ascending order, or otherwise if I am using default natural sorting order. Default natural sorting order for numbers is ascending. Default natural sorting order for string objects is alphabetical order. Remember this one. For string alphabetical order, for numbers ascending order, right? Sir, if I am using normal order, normal ascending order, then comparator method returns simply null. But there is no special sorting. Default natural sorting only we use it like. Okay, that's all. So can you tell sorted set interface defines how many methods, Anna? Six specific methods are there in the sorted set. These methods applicable sorted set related objects, but not a normal set. On the hash set you can't apply, on the linked hash set we can't apply. These methods are related to only what? Sorted set, right? Okay, add sorted. What the last point you took? Can you spell out? Okay, well, add sorted set interface defines. Sorted set interface defines. Sorted set interface defines the following. Sorted set interface defines the following specific methods. 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 Okay, better to take from the screen first. Take object here, just listen few minutes and then you can take object first and return. Here object first returns what? First element of the sorted set. Next object last returns last element of the sorted set. Head set of object obj return sorted set whose elements are less than obj. Are you getting? Before obj, less than obj. Tail set of object obj, okay, returns the sorted set whose elements are greater than or equal to obj. Correct or not? Greater than or equal to obj. Okay, equal symbol also there. Next sorted set subset of object obj1 comma object obj2 return sorted set whose elements are greater than or equal to obj1 and less than obj2. Are you getting? Under less than obj2, greater than or equal to obj1 but less than obj2. Next last method also I explain. Comparator returns comparator object that describes underlying sorting technique. If we are using default natural sorting order, then we will get what? Null. Then immediately you ask us, sir, which is the default natural sorting order? For numbers, which is the default natural sorting order? For numbers, which is the default natural sorting order? Ascending order. For string objects, which is the default natural sorting order? Alphabetical order. Is it clear for all of you? Okay, take these methods first. Take clearly. Sorted set interface contains the following 6 specific methods. Object first returns first element of the sorted set. Object last returns last element of the sorted set. Sorted set of object obj return sorted set whose elements are less than obj. Returns the last element of the sorted set. Return sorted set whose elements are less than obj, whose elements are greater than or equal to obj, greater than or equal to obj1 and less than obj2. End conditions take special care. Completed, I hope. Returns last element of the sorted set. Returns a sorted set whose elements are lesser than obj. Completed, I hope. Returns a sorted set whose elements are greater than or equal to obj. Next, the return sorted set whose elements are greater than or equal to obj1 and less than obj2, like. Completed, right? Okay, so that's all. Just take a note first and then you can take this example. Note. Here we used one word. Have you remember default natural sorting order? You should have clarity. Default natural sorting order for numbers and for normal numbers. Which one is the default natural sorting order? Ascending order. Remember this one. For numbers, default natural sorting order means what? Ascending order. For string objects, sir, for string objects, which one is the default natural sorting order for string? Which one? Alphabetical order. Alphabetical order is nothing but like. Clear for all of you, right? Okay, this add. Take a note. The default natural sorting order. The default natural sorting order for numbers. Default natural sorting order for numbers. Ascending order. Default natural sorting order for numbers. Ascending order. Default natural sorting order for numbers. Ascending order. And for string objects. And for string objects. Which one? For string objects, alphabetical order. And for string objects, alphabetical order. Okay, so this one, because I'm going to use minimum 100 times default natural sorting order, like this one. Customized sorting order means our own. How we can implement that part, I will take care. Okay, now take this example. Take this one. This is the sorted set. Of course, example. First means 100, last means 120. Head set, tail set, subset. Next, comparator. hope is that clear, right? Take clearly. So first, last, head set, tail set, subset, next comparator. Okay, now completed, I hope.